Good evening, Joachim. Thank you for having said yes to this interview. I am very happy that I can ask you some questions. And my first question has, of course, something to do with COVID. We are in the middle of the fourth COVID wave, and apparently there is a new wave coming from Colombia. Why does the course of corona occur in waves?
Oh, yeah. Okay, good question, and thank you for giving me the opportunity to explain a couple of issues surrounding this pandemic. A popular model in epidemiology is the SIR model. S for susceptible, infectious, and removed or recovered. Okay, three rather simple differential equations allow us to model the transition from susceptible to infectious and finally to the removed population, which decisive for the intensity and frequency of the waves is the amount of new susceptibles entering the system. Okay, with COVID, the latter has not really occurred, that people recovered and were susceptible again. And therefore, this traditional model does not really explain the waves we observe here. Rather, the following is a plausible explanation for the waves. The infection process can be modeled via contacts, numbers, frequencies, and we have very good illustrations to illustrate these contacts and how they multiply. A number of parameters play here a role, and in the media we were overwhelmed. The media were filled with these parameters, like the R value, which expresses the number of people an infected person on average will infect. Or other parameters are age, the season, the weather plays an important role, as it is with the common influenza. Okay. Also, the occurrence of new mutants play a role. All these parameters are not fixed, but several of them depend crucially on our human behavior and can be changed and through our compliance or our careless dealing with these rules, like distance holding, hand washing, mask wearing, and how strict we obey to a lockdown. The time of the year, and consequently, if we are staying outdoor or indoor, also plays a role. Okay, and we have these waves because the parameters change. In addition, these phenomena are well known from modeling time-delayed effects. We have here time-delayed effects. People respond with a time delay. It's a bit similar to when you take a shower and the water is too hot. What do? You turn it to cold. That takes a while till the colder water comes through the pipes. So you get impatient and you make it even, you turn the water even colder than you like it. Well, what's the consequence? Very soon you say, oh, it's too cold. I have to change it. In particular, impatient persons change it and change it to, and the water gets too hot. And that causes all these waves that we observe here also. Yeah? If the intensive care units in the hospitals are filled, then the governments impose strict rules. It takes a while till the stricter rules are implemented. And then when they are implemented and the numbers go down, people feel like, oh, there's no problem anymore, and move around and have parties, and then the infection rate goes up again.
Thank you for the explanation on the waves. Now we all talk about vaccines. As you know, the politicians try to convince people in all countries to get vaccinated, but there is some hesitancy in some countries more than others. And there are many reasons for the hesitancy. Some are religious, some are perhaps irrational, but some want to, have arguments based on numbers. And these are often very wrong, as you may have observed. Could you tell us about this hesitancy and the statistical literacy we should need?
I mean, sure. I'm an applied mathematician and not an sorry. I'm an applied mathematician and not a virologist. But to all I know is that the vaccine is the best protection for the entire population. And epidemiologists can tell us, and epidemiological models can verify that we need a certain level of vaccinated people to really have to be safe of the virus. And this figure could be, some say 80%, others say 85%, but the current number that we have in Germany nowadays, with 60% being fully vaccinated and about 65% having at least one vaccination, is not enough. As you said, some people have very irrational arguments, and it's very difficult to address these concerns and to take those away, because it's very difficult to have a rational discussion with people who believe in conspiracy theories. And some people have some reasons that and they may be approachable with rational arguments. Yeah. And of course, or as we hear in the news and as we all know, the vaccination is not a 100% protection. From the very beginning, we were told that, for example, BioNTech provides a 95% protection. And one of the lessons that all of us learn these days is that there is nothing in life without any risk. And it's possible that vaccinated people also contract the virus. But it's still highly recommendable. Even a vaccination is still a very strong protection. And I prepared a little calculation for you to demonstrate and to calculate why it's so much better. You are so much better protected when you are vaccinated. Can I show you this short?
Thank you. I would love to. I would love to see it. Thank you.
And I have to share my screen.
Share screen.
The following illustration is based on data from the Robert Koch Institute of the first 3 weeks of August this year and refers to people between 18 and 59 years of age. In Germany, during that time, 3,797 have been hospitalized due to COVID, and 94.4% of those being hospitalized in that period were not vaccinated, while the remaining 5.6% of those hospitalized had been vaccinated beforehand and still contracted COVID to a degree so severe that they had to be hospitalized. We also know that 61% of this population had been, in Germany in total, had been vaccinated. With these three quantities, we can compute something called the conditional probability of a non-vaccinated person to be hospitalized. And applying the formula for conditional probability, you see the result in line 4. And we can compute the same expression for the vaccinated people. And in the next step, we form the quotient of these two expressions. This is called the odds ratio. And notice when you form the quotient of line 4 divided by line 5, the quantity P of H, which means the unconditional probability of a person being hospitalized, cancels out, and we get a concrete number for the odds ratio. And in our case, this number is 26.37. It can be interpreted as follows. A non-vaccinated person aged between 18 and 59 is 26.37 times more likely to be hospitalized than a vaccinated person. Yeah. Even vaccination does not provide 100% security against COVID, and even vaccinated people may end up in hospital due to COVID, but the probability to be in the hospital due to COVID for a non-vaccinated person is 26 times higher. We can do the same computation for the more vulnerable group of people in the age range 60 and above. And here, based on the data from the Robert Koch Institute of the first 3 weeks of August, we compute an odds ratio of 18.4, which means nothing else but that an unvaccinated person aged 60 or above is 18.4 times more likely to be hospitalized than an vaccinated person.
Great. This is great. And this is very important for our students because, we learn conditional probabilities, we learn odd ratios, Bayes' theorem, and we see here how useful these instruments are. So I will now switch to the topic of your participation in math education and in particular in statistics education, asking you first, how did you enter this area? What was your, your road?
Okay.
Your life?
Okay.
How did you get to become
sure,
a statistics
I got
educator?
early on to studying mathematics with a diploma in Bonn, which included also pure mathematics. But I always have been fascinated by the mathematics of uncertainty. And so it was clear to me, that after I finished my studies and also, got to know more about the world by traveling around and doing non-academic work, mainly in the social area, that I wanted to do, to apply my mathematical skills to understand statistics and to help people in the world to make sense of their numbers.
So where did you get you got your PhD in California, am I right? Was
Yes.
that in statistics already?
Well, my formal degree is in applied mathematics, a PhD in applied mathematics from the University of Southern California, but with a focus on statistics. In that context, it was still very theoretical mathematical statistics with wavelets, and but my interest became much stronger in applying these skills to solve problems, to contribute to problems that are burning to humankind, and to help people to get a grip on these issues. And in the whole world, we are reasoning with data from global warming to unemployment rate and migration and many more, and inequalities in the world. And nowadays in Germany, we have the election campaign. In public debate, everyone throws around their numbers and reasons with them, and of course numbers by itself are innocuous.
Okay.
But it's up to us to interpret. We give them meaning by visualizing the data and interpreting them.
So the next question I want to ask, you are today in statistics education. You were the president of the IASE, and now I think you're vice president, or I don't know, how do you call it? And I would like you to say a couple of words on this association and on the importance of this association and, the diffusion of statistics education in the world and the importance of it.
Okay, I mean, just the last year was a extremely vivid demonstration of the importance of understanding and making sense of the quantitative evidence that we gather around the world. And when I talk about making sense of it, that does not only apply to using some formal statistical procedures. A lot of it has to do with critical thinking, and you have to ask about the pedigree of the data. How reliable are the data? Where do they come from? Do the data really provide an answer to the question I have? Yeah? And these are highly important questions. I mean, the International Statistical Institute has its slogan, statistics for a better in my class. I had my students read the illuminating book by Cathy O'Neill's on weapons of math destruction. So we have to be critical, but of course, I mean, I'm deeply convinced that a sound understanding of statistics and statistical literacy is a cornerstone to make the world better.
Yes, but schools have to accept it. As we know, you see, it has to be taught at school, in school. And we know there is a certain reluctance to include more and more statistics in the curriculum because it somehow belongs into math, but math is very, intense. And there are many other mathematical subjects. So the role of statistics education in some countries is still not big enough. Would you agree?
Okay, I mean, sure. I mean, I came to statistics through mathematics from my background, but that's like, I mean, statistics involves so much more. And nowadays, in times of big data, we enlarged the field of statistics and call it data science. And data science and statistics, some people say, yeah, well, you also need a lot of computing skills to make use of modern computing technology. But even this is by far not enough. And statistics and data science is, I think, I mean, part of almost any area of modern knowledge.
Yes, but continuing, I want to, what I want to say is that we want school students to learn some of it. You see, they cannot go very deep, but they should be able to understand the formulas that you just were presenting. As student in 10th class or whatever should be able to understand that. So this is what we talk about today.
I mean,
and you're
sure. I mean, mathematics instruction in school plays an important role, no doubt. I mean, without some basic mathematical knowledge, you would not be able to follow the brief deduction that I presented a few minutes ago. But understanding data is also part of many subjects in school and should be included included in social science and in natural science, in physics and biology. What do? You collect data and try to make sense of it. Yeah, and the same is true in social studies, but very few.
So would you suggest, would you suggest, you see, if we try to put statistics as one of the areas in mathematics, we have problems, as we have seen, for instance, in Germany, that this, the time left for statistics is relatively short. Would you suggest that, in the biology class or in the physics class, etc.,
statistical literacy should be a general skill in this general competency, like media literacy, that spreads out through various subjects. And for example, a while ago, I did a wonderful seminar with a colleague from political science. And because he told me his students never have any encounter with thinking statistically. And this colleague got very excited, and we decided to go on and continue with this cooperation. Because many teachers in, let's say, in social science, they are number phobic. And but why is that? Because they never learned how to understand and deal with these numbers.
Yes,
I mean,
that's very
it has to be said that statistics has a pretty bad reputation, because in the past it was dominated by formal mathematics, and only a few of us survived these type of instructions.
Thank you. Yes, I agree with you. And, I'm always hoping that, as you say, that statistics will be part, for instance, of the history class, of the biology class. Historians need, of course, a lot of statistics today. And, of course, math, but of course, also physics. And that is an ideal that we work for. And I'm very grateful for your very good explanation of the COVID situation, the hesitancy, because that was showing us precisely that some understanding of conditional probabilities is very, very useful to tackle and deal with the question of whether I will get vaccinated or not. I got vaccinated, of course, and you too, of course. So, Joachim, thank you so much. And we close our interview here. Thank you for these 30 minutes of very interesting talking. And I hope to see you again soon. Bye-bye.
Yeah, my great pleasure. Thank you very much.